Okay, some caster angle tests. First, we have the classic motorcycle wheel. Of course, when parked and not moving, it's tilted to one side. However, the moment you start to move the vehicle, it self-centers. And of course now when I'm going backwards, it doesn't. But when I'm driving, I don't know, yeah, come on. When I'm driving, the wheel has the tendency to self-center. Of course, it needs rear suspension as well, so that the rear wheels are not just static, and preferably also a front suspension. But it is stable in a straight line without any motors or whatever. Now let's take a look at the second setup. Okay, here we have the second setup. Of course, like the trolley cartwheel. Now with this setup, initially we can see that, sure, it does follow a straight line. It wants to follow a straight line. But what the problem here is that every slight disturbance of the rear wheels, for example, will start wobbling the front immediately, because it's not stable. It's only stable on a perfect flat surface. And because the rear wheels will always encounter different obstacles, this setup is inherently unstable. It has no mechanism to self-center itself. And at speed, the wobble can become uncontrollable. That's why it breaks parts and makes the vehicle very hard to control. Okay, this is now the simplest double wishbone setup I could make. It has caster, it has kingpin inclination, suspension, it does not have bump steer, and as this setup basically is, the faster you go, the more stable this is. The faster it goes, the easier it is to control. And because of the geometry, the bumps really don't have any effect on the steering axle. I can barely feel any resistance when driving over any bumps, and my hand is quite a big bump. So if you want a real stable fast car, I would suggest you install this front suspension. I will give you pictures so you can build it yourself.